Welcome to the deep dive. Today we're tackling something really quite shocking. A medical mystery, actually. How are people dying from rabies, even when they've been fully vaccinated?
Yeah, it's deeply concerning. And this isn't just a theoretical risk.
No, exactly. We've seen recent tragic cases like those 3 children in Kerala, India, and there's a global study from 2024 that identified 122 cases like this worldwide. It just seems like such a contradiction.
It really is, because, rabies is almost always fatal once symptoms show up. It's brutal.
100% fatal, practically.
Right. But flip side is, it should be almost 100% preventable with the right vaccination after exposure.
So what's the disconnect? Our sources seem to point towards something specific, don't they?
They do. We're looking at what you could call a missing protein crisis. It sounds technical, but basically a key part of the rabies virus glycoprotein is either missing or just not adequate in some of the vaccines people received.
Okay, so the mission for this deep dive is pretty clear. Figure out what's going wrong here, why this critical protein is sometimes failing, and what we can actually do about it.
Yeah.
To save lives.
Exactly.
All right, let's get into those cases. Like in Kerala, these children had dog bites. They received the full vaccine course. What makes their deaths so disturbing in this context?
Well, what's really crucial to understand, even if you know a bit about vaccines, is how this glycoprotein works. Think of it as the wanted poster the vaccine shows your immune system.
Okay, so the immune system learns to recognize this specific protein.
Precisely. But it's not just about it being there. The protein has this incredibly delicate 3-part structure. It's fragile.
Fragile how?
Temperature is key. If it gets too warm during manufacturing, or if there are other mistakes in processing, or maybe failures in quality checks, that delicate structure literally, it unravels.
Unravels.
Yeah, it loses the specific 3D shape the immune system needs to see. It's like, imagine a key losing its teeth. It might look like a key, but it won't open the lock.
So the vaccine could look perfectly fine, pass some basic tests maybe, but be completely useless immunologically.
That's the terrifying reality. It means just having a vaccine isn't enough. The quality, the integrity of that protein is absolutely paramount.
Which brings us to manufacturing and that cold chain you mentioned. It sounds incredibly sensitive.
Oh, it is. The production process takes, 3 to 4 months?
Wow, that long?
Yeah. And during that whole time, it needs to be kept strictly between 2 and 8 degrees Celsius. Constantly.
2 to 8 degrees. That's a pretty narrow window.
It is. And any break in that cold chain, any deviation, can essentially destroy those vital proteins.
And in developing countries, this becomes even more challenging, right?
Absolutely. You've got several factors piling up. Limited labs that maybe can't easily test for these specific protein problems.
Okay.
Then there's economic pressure, maybe buying cheaper vaccines that don't meet the highest standards. And then crucially, just poor cold storage infrastructure. Think about rural clinics, places without reliable electricity.
Right. Keeping things consistently cold is tough.
Exactly. So it points to a potential loophole. Either the initial tests, say from a central lab like India's CDL, weren't catching this specific protein failure. Or maybe the problems, like cold chain breaks, are happening after the vaccines leave that controlled environment.
Which is really worrying. And this isn't just India, is it? The sources suggest this is a wider systemic challenge.
It absolutely is. It affects public health systems in many developing nations where millions rely on these vaccines. It's a global issue.
But okay, let's pivot slightly. Because there is good news, right? Research is providing solutions.
Yes, definitely. And some are quite revolutionary. We're seeing advanced testing methods now.
Faster tests.
Much faster. Tests that can check protein levels in maybe 30 minutes instead of taking days.
30 minutes, that's a huge leap.
It's massive. It means potentially faulty batches can be identified and pulled before they even get distributed. Think of the lives and the resources saved.
Okay, what else?
Well, mRNA vaccines, similar tech to some COVID vaccines, are showing really promising results for rabies.
Why are they better in this context?
Manufacturing tends to be faster, and the final product often seems more stable, so it could directly address some of these protein integrity issues we've been talking about.
Interesting. Anything else?
Yeah, there are new 3-dose vaccine regimens that seem just as effective as the older 5-dose ones.
Oh, that's huge for compliance, surely.
Yeah.
Especially in remote areas. Getting back 5 times is hard.
Exactly. And maybe the biggest potential game changer, heat-stable formulations. Vaccines that don't need that constant fragile cold chain, that could open up access dramatically.
So the science is moving forward. Countries are already starting to implement stricter controls
Yeah.
and better testing too, right?
Yes, several are upgrading their systems, which is really encouraging.
Okay, so let's bring us back to the listener. If you or someone you know needs rabies vaccination, what's the key takeaway here? Well, first off, don't delay treatment. Even with these concerns, a potentially imperfect vaccine is far, far better than no treatment at all. Rabies is just too deadly.
Absolutely. And basic wound care is vital. Wash the bite thoroughly with soap and water immediately.
Right. And always, always complete the full vaccination course. Don't skip doses.
Crucial. You could also, ask the clinic about storage just to inquire if the vaccines have been kept properly refrigerated. It shows awareness.
And if, heaven forbid, you suspect a vaccine might have failed,
Report it immediately to the health authorities. And for really severe exposures, you could even ask about getting an antibody test after the vaccination course to actually confirm you've developed protection.
good practical advice. So wrapping this up, it feels like the core message is that every single vaccine failure is a tragedy we could and should prevent.
It really is. The technology, the science to solve this specific crisis, it exists. We have rapid tests, better vaccine formulations are coming.
But it needs more than just science.
Exactly. It needs political will. It needs investment in quality control and better infrastructure. And it needs coordinated global action. It's not just about discovering a vaccine. It's about ensuring its quality every step of the way, from the lab right to the patient's arm.
Making sure the science actually reaches people effectively.
Yes. And remember, the vast majority of people are successfully protected by current rabies vaccines. They work incredibly well most of the time.
But nobody should die because the specific dose they received happened to lack those crucial proteins. It's an avoidable failure.
Precisely. And that leaves us and you with a final thought to consider. If we have the scientific tools, what are the other barriers, economic, political, logistical, that stand in the way of ensuring everyone, everywhere, has access not just to healthcare, but to quality, effective healthcare?
Something important to think about. Thank you for joining us on the Deep Dive.